Several weeks ago, I crashed and totaled my Active Aerodynamics build car, and I've finally gotten it all back together. Now, if you're not aware, it's been a build saga that actually started with a wheelie bar and then progressed into Active Aerodynamics that correct themselves for the pitch of the car, so I don't actually have to rely on any driver talent because that's something I just don't have. But in this build, I have added rear downforce and belted tires, and I'll explain this here in a minute. For this video, we're gonna test high-speed performance, of course, but we're also gonna test acrobatics and jumps. That's right, I wanna take this thing off a ramp to see if it can actually handle a ramp, or if it'll try too hard to self-correct and just spear the ramp with the wing on the front and then just glitch out. Now, the rear wing was added to give me some downforce on the back of the car to balance the front and the rear aerodynamic forces, so hopefully the back end is less prone to kick around like we saw happen in the very first video that just totaled the car and trashed everything. But I've also noticed that the tires can still balloon a ton, and if the differential does what differentials do, that can lead to just one tire ballooning a ton while the other stays the same, and it'll definitely send the car off course, which could have happened as well. We can really see this happen in the slow motion launch footage where you see just one wheel getting huge and the other staying pretty much the same size as when they're stationary. I can fix the ballooning by using belted tires, which these new Hoons are. You see, in an unbelted tire like I originally used, it's just a rubber tire glued to a plastic rim, which has really low tensile stiffness, and under high speed rotation, it allows the tires to expand out under a centrifugal force. But with belted tires, a belt is bonded into the tire to provide an increase in tensile stiffness to prevent this ballooning. Some people literally just add tape to the inside of the tire, and that usually works relatively well. We can actually simulate the centrifugal forces that these tires see in Fusion 360 to see the massive difference between belted and unbelted tires. On the left, we have standard rubber tires, and on the right, I have a belted tire with a 20 thousandths thick band bonded to the rubber. The deformation illustrations here are both actual scale, and they line up pretty well with what we see in the real world. On a side note, this will likely be my last Active Aero build with this chassis because I may or may not be working on a car that rhymes with Brabham BT46B and Chaparral 2J. So make sure to subscribe if you're interested in more Active Aero so you can see just how hard this thing fails. Now that we have the tweaks out of the way, let's do some real speed runs. And I had to go to a smaller area than I usually go to because that area was closed, but I still hope to be able to top 50 miles an hour. After a bit of warming up, I was definitely ready for some tests. Infuriatingly, is that a word? I still had issues with the wing folding under the car as soon as I started to ramp up a downforce, and this was especially true if I hit any bump at all. The wing got a little scratched, but it was surprisingly still good to go after a few times of this happening at over 40 miles an hour, and trust me, this happened way more than I want to admit. After tightening it finally enough to the point of nearly breaking, I decided to push the limits and see what we could do for a better top speed run. This time I was finally able to get up around 53 miles an hour, but I hit a stupid blue reflector that folded the wing up, and I crashed, of course. Of course I crashed. What else would I do? I know I do have more speed to go though, because this speed graph isn't even close to flattening out. If you look, I'm just having to go on the brakes way too early because I have limited space. With more space, I definitely know I could get over 60 miles an hour in this vehicle. I quickly had enough of the speed runs because, to be honest, they're a little boring, and I wanted to see what this car could do in something other than a straight line. And this was just me bashing around the parking lot. With the added downforce in the new Hoons, the car does stick pretty well, but I'll admit that it sits up way too high and really isn't set up properly for a speed run, so it's still prone to flipping. And when I was finally happy enough with the road course footage, it was time to see how this thing reacted when it was airborne. Because who doesn't want to see this car fly, right? The first step was jumping out of the truck bed, and we can actually see the front wing try and correct itself to stay level. But when it hits the ground, you guessed it, it folds itself up. And so it turns out that the GoPro style designed front wing mount that I used is pretty trash, so I wouldn't recommend using that yourself. That was cute and all, but what about an actual ramp? Is the car actually gonna jump? Will it snap the wing off, or is it just gonna like fold up on itself because it's trying to correct for the angle and just glitch out and fail? And there's only one way to find out, right? That solves it. It actually will jump and I will crash it. And without the wing though, it does have a lot more control in the air, so I can do cooler tricks, have more fun. I'm glad the wing is gone now, as a matter of fact, because I'm so tired of dealing with that sensitive piece of just not good enough. Now I should mention that throughout this entire video, I have the Traxxas stability management system on, which means it's actively trying to keep me from losing control. It's just not good enough to compensate for a driver as bad as me. When I rotate the car in the air, you can see the wheels counter steering to try and prevent me from sending the car out of control, and that's kind of how you can tell the system's actually working. I also had the steering inputs turned way down, so I can't inadvertently slam it into a curb like we saw last time. I don't know if it was my fault, but I want to make sure that I can't screw this up as easily as I have in the past. If you're curious about the simulation I ran earlier in this video, it simply analyzes the response of a part, a tire in our case, to a rotational load. In our case, it was a load called a global angular velocity, which I'm basically just setting to the max tire RPM. And this is really useful in understanding how high rotational velocities like these tires see will impact the design and help us improve without just guessing and checking. And as you saw in this case, I actually was able to predict ballooning of the tires pretty well. I should add that these Hoons are pretty stiff tires, so they're not going to perform too well in anything other than really smooth surfaces. And it would take an entirely different simulation to understand how the belting impacts stiffness over different surfaces, so that we could really understand ride quality. Again, this is probably the last active aero video I'll do on that chassis, but please stay tuned for the fan car and cross your fingers that I get the pressure drop I'm looking for so that we can actually get the performance I'm hoping in the huge downforce numbers that some of the other race cars saw throughout history, like the Brabham BT46 and the Chaparral 2J. That's really it for this one. Please let me know if you have any questions or leave a comment, and thanks for watching.